So hello, today we are running stainless steel parts. Stainless steel parts for some food equipment, and they are all punched. We just need to run one side, the other side is fine. Also because, and that's a peculiarity, on the so-called good side here, you have a clear PVC coating, which is not laser grade because otherwise it would be marked so. And you can see from the bubbles on the corners and so forth that the tack of it is very, very low. It will come off pretty much immediately. So normally we can run on our DM1100C edge rounding machine. We can run PVC coated material, but of course they should be laser graded PVC coated material so that it doesn't get pulled off by the cross belts. In this machine we have regular 4060 aluminum oxide, not the ceramic grit purple, which would be a little bit more aggressive, of course. So we are going to run these parts only from the bottom, from the burr side. We have some smaller parts, and then we mainly have some larger parts. So after closing the hood, all we will do is we turn the main switch on. You get the power on light. We are going to set our material thickness, very simple, to about 1 millimeter, because that's where we are with the material. Actually, the first thing that we're going to do is we're going to set the machine to 3 millimeters, because that's where I want to set my belts. The belts, as you can see, I don't know if you can see this here very well, they are really high. So we're going to bring this closer into the middle 50s. There we go. Then we're going to turn them on. We're going to turn the cross belt speed down. Conveyor belt is running about 3 feet a minute. That's fine for now. And now we're going to bring the belt speed down to where we can hit it, where we can hear hitting it, the conveyor belt. Right there. And that tells me that we are about 3 millimeters below material surface. Now we're going up with the belt speed, and we are going to 1 millimeter, which means we are already pretty good into the belt. Maybe we ease that up. We are at 49.1 here right now. Maybe I'll go to 49.6. I'm going a half a millimeter up. Here is our first part. You can see that we don't have a lot of draft, we just have very sharp edges from the punches. With the machine, with parts of this size, maybe a 1600 would be the better machine for more throughput. And we give this the first try to see what the result is after. Again, our potentiometer is set to about 2. That represents about 3 feet a minute, maybe 2 feet a minute, better for this thinner material. There you see the parts coming out. You can already see on the line, they have a white line, and that tells me that we have a very nice edge mounting here. We have a little bit less going on in the corner here because the brushes can't really reach into that. You may need, if that is critical, then you may need a second pass at a different angle. But overall, these are really good results. There wasn't much more to do than that. That's how easy it is to set up a DM1100C and to get the correct belt pressure. And you you can see here that we are really working the material because you see the imprint of the part on the conveyor. It's a very good edge. Now, the next one, we are going to run a little bit slower just to show you that as well. 2 feet a minute, but therefore we're going to be lighter on the conveyor belt, which means we are coming up another 0.5 millimeters. This actually, so this is a coating side. This actually does have a burr on this side because it was probably sheared on something like a fin power machine or a Salvagnini that have a shear integrated. So we're going to have to try to run this also afterwards. Here the shear burr is on this side here, and therefore then the shear burr is on this side here on the PVC side. So we may have to do that from both sides. There we go. So now we are going slower, but we at the same time we are being far more gentle on the conveyor. And what we can do right away in succession with this, so you can see that, we will run these small parts. Same material thickness, give or take. In that material thickness, the setting of the machine for material thickness is not really that critical. It's just little material thickness, if you know what I mean. So, you see the productivity of the machine when you fill the table. Offset, so we want more throughput and pay a little bit more for conveyor belt and for brush block, or go down and make it easier on the material. All other edges, including the small holes, are good. So I just had to return that real quick. I'm doing the single hand operation and at the same time camera, so excuse sometimes that you are not fully in the view. All right, so now if you want to run this to remove the burr here on the bottom, what I'm going to do is actually, I'm going to leave this setting, but I am going to go back to about 3 feet, 4 feet on the conveyor, and we'll see how much of the PVC we'll be removing. So I'll flip this. Now we have the PVC side up, and like you can see already here, the PVC is not on there. So this will be an issue. There is no if, but, or when. You cannot avoid it. So what I will do in this case, I'll actually run it parallel to the grain. I just hit the safety flap, that's why the machine turned off. I will run this parallel to the grain so that if we do remove some of it, at least it won't be so obvious. Okay, we won't have a cross edge. So we'll turn this on again, turn this on again. Off we go. Here, where the PVC is solidly on, we should not have an issue. We will just have the issue in the corner with the PVC on the jaw. You can see it moving a lot faster. I'm doing that in order not to put too much pressure on the part. Here you can see basically where the PVC is not doesn't have good view, but also on the edge you do not have the distance you have to have better here. This is where it was on. But it's not too bad because it grains right parallel to the ground. So, if you want to avoid that, then you need to run parts with laser grade PVC. The edge itself is really nice. No issues here. So, we will try this one more time. Now we will go lighter. So I'll go up another millimeter or so to 51, and we will go to 4 feet, 5 feet of it on the conveyor belt. PVC is off before we cut. So now you see that we are removing much less PVC, but of course we will also get less inside. We still have the issue with the PVC will go, but because we are parallel to the grain, it is better. And this is the edge we need to check for the burr, and there it's going so light we still have that burr, so that didn't totally remove it. So ultimately the solution for that is that you really need a laser grade PVC, and then you will be able to solve these problems. On these long parts here we don't have this issue because the burr is all punched all the way. It feels like it? No, it's not. That is also seared from the top, so it would be the same. But I can feel it here. The burr is here and here, and here it feels like a shear. Yeah. So what we will do for that still is we are going back to higher pressure, 50. And to 3 feet a minute. Because these parts do have quite a bit of burr on the punch line. There seems to be a little bit of an issue with the die clearance and the punch alignment for the parting tool. And when we put the part on, we might need to make sure that it will clear the tape. But again, we can run several of course side by side. And we'll just try these two at that setting, and then we'll go either lighter or heavier depending on how they come out. can see that right here at the nibble mark, we still have some remaining burr, and actually in here, because this is like folded over. Like I said, this is a die clearance issue. We really moved over a lot of material to the bottom. Don't know if you can see it in the video. So now we will go even a ½ millimeter deeper. We can do that. Be hard on the conveyor, and we're gonna go to about 2 feet a minute. Go. In terms of the belt wear, it doesn't matter where you place the parts because the belts go perpendicular to the feed direction, so they're self-dressing. They will always remove the same amount. What we can also do with these kinds of parts, we will mount the purple ceramic block, and I have a different machine. On our demo truck, I will run these also on the purple ceramic block to check if this doesn't any drop, especially in this corner, but also with the burr on that front edge. This is already a lot better than it was, but it still is protruding, even though it is not sharp anymore. And I lost all the sharpness because just that little geometric protrusion. Once you punch with the correct die clearance, it never occurs. Then it will be like these edges. You can see are really nice. Also these edges are really nice. It's just that one where that part is like operating. By the way, I will mark all this so that you know what we ran with which parameters. So these were medium pressure, these were heavy pressure, these were 2 feet a minute, these were 3 feet a minute. So now all we have left these big panels which have offset, they have form, and we need to run this side. Again, we have one burr here and one burr there. Yeah, what we need to do here is we need to set the machine to about 3/16 because this is sticking up. Ultimately, you want to run a part like this probably on a wooden board where you make some relief for these forms and get them off the table and have them lay flat where you can apply a lot of pressure to the edges. So I'm going to set that machine to 4.5. You can hear the conveyor belt go quiet. So that's about 3/16 of an inch. But therefore, I can increase my grinding pressure. And I'll put that to 48.7. Just another millimeter down. We go, and it's going to just listen to the sound. is a little heavy. So on the fly, I'm just gonna bring this back up to 49 again. It makes a little bit more sound, of course, because it's not, the edge is not supported. You can see it snapping here. Right? Which is fine. Doesn't do anything, any damage or anything to the machine. Really beautiful. Very good. Now, just so to show you this, you can run a part like this also with the upforms up, because these upforms are very smooth. But then again, we want to bring the belt up about 50, and we need to bring the material thickness down again to about 1, because the actual material on the belt is not more than 1 millimeter. Remind you that we have the PVC coating off now, and we are going to peel some of that PVC where we don't have good pack, it's not adhering. You can see some of this PVC coming out. Of course, it's really wide. This is more a demo for you that these parts can run in general, but they will need the correct PVC coating. I'm repeating myself, I know that, because I don't have anything else to do while I'm making this video. So ultimately, we ran this part a little bit too hard because, and you can see that the brushes can take the upform, but the brushes also took the PVC coating off the taller upforms. These are probably 1/4 inch, and even the lower upforms. So this PVC coating is not very it's thick and very durable. So that would not be a good process for this part from this side, no matter what. The last part that I'm going to run the right side up again. So I'm going back to 4.5. And here down to 49. And we're going to run this from the bottom. If we conclude this test, I'll put this part here for right now. On the bottom side where we don't have PVC coating, the edges come out good as long as we have a good punching tool. So issue number one that we have is we would need a more aggressive media, and we have some, and I will run that later, and I'll mark it on this part to show you what that can do. This is on our demo truck. It's not so easy to make a video, especially with this large part. That's issue number one. Issue number two is you have also some burrs in these small contours which are really excessive, and at the same time in a very small contour where the machine has a difficulty to reach it. So you may have to remove those manually, or again change your punching process. If you had a laser cutting process or something like that, this would not be an issue. Number three, if you want to run the side because you use a shear which is protected by PVC, you would need to use a laser tack grade PVC in order to protect the edges completely and not go in. You can check whether running parallel to the grain is good enough for your appearance, where you say we don't mind that, and for that I will peel that back a little bit so that you can see what that looks like if we run parallel. I ran one part not parallel, and then you will see how you get a cross grain. So this is what that would look like. So that is still pretty acceptable, even with by removing the PVC coating. Number four, the parts with the upforms. The upforms are not too tall to run through the machine. That'll be fine. And then, as you can see on this edge, we can even hit the edge. However, on those upforms, then again, the PVC coating would be removed. So you would have to run that parallel to the grain and see if that then is still good enough for the aesthetics in your part. And other than that, I think this concludes our business. These parts here ran no trouble at all because they are completely punched. They only need to run from one side, and I think you will like the edges very much. Thank you very much, and have a good day.